Thank you, Vidya, and
Yeah, thank you, ma'am.
welcome all to today's session on Introduction to Generative AI and Agentic Automation, which is, I would say, one of the most exciting and rapidly evolving areas in the world of tech. And I'm glad to see you all with great enthusiasm. I'll share my screen. Maybe Vidya, can you confirm if my screen is visible?
Not yet. Yes, it is.
Okay. Okay. So as Vidya mentioned, myself, I have an experience of over 6 years, and I'm a tech lead in L&T Technology Services, and 3 times MVP, and then community trainer, and also LinkedIn Top Voices. You can quickly scan the QR code, and which will redirect to my YouTube channel. So that's about myself. So yeah. So in today's session, we'll be starting with robotic process automation, which is RPA, and then how it evolved to AI, artificial intelligence, how we are going to involve artificial intelligence into RPA, and what is the next step, which is generative AI, also the agentic process automation. We'll see what are agents, what is a large language model, what is an LLM, all those things we'll see, and then you'll have a clearer understanding at the end of this session. So, firstly, introduction to generative AI. Before knowing about generative AI, we need to know what is artificial intelligence and what is RPA basically. Let's start with RPA. So, RPA is nothing but robotic process automation, which is a technology which creates software robots. So, these are not hardware robots, these are software robots which helps you to automate repetitive and rule based tasks. The task has to be rule based and logic based. Typically, what human does with logics that can be made using RPA. And these bots are nothing but these will exactly mimic human actions. Let's say you have an Excel, you have to fill an Excel with 5 records. You open an Excel, you type something, you save it, and then you store it in some folder, right? So these are human actions. These actions, if you make a software robot to do exactly these actions, that is nothing but an RPA robot. So that's what an RPA robot means. So before getting into next step, let's understand. Can you mute Vidya?
One second, Krishna, I'll get hold of it.
Sure.
Yeah, Krishna, you can unmute yourself and go ahead with the session. I've muted everybody.
Sure. Thank you.
Mm.
Okay. So now we understood what is RPA, right? So let's not go with definitions. Let's understand all these terms with a simple story. Okay. So meet Rahul. So he's in his manual world. He have a lot of invoices, and he has to deal with these invoices. So he works as an accountant. Every morning when he goes to office, he opens emails. He downloads invoices from emails. He'll check each invoice manually. Let's say this is his invoice. This is invoice. He'll check the company name. He'll check the rest of the details, and then he'll check the final value. And then he types that into an Excel. And later in his office, whatever he have some steps, manual steps, he'll do that. So he spends 4 hours of daily his time doing all these activities. So now, as the first step, we have RPA, right? So this is exactly an RPA use case do, which we can create a robot which can exactly do all these things. So what robot does? Robot can go to email, which is a rule based. It can download invoices. If the invoice is rule based, like if it is a common one for all, if the structure is common for all invoices, it can read with regular expression. You can get the required detail and then enter it in some Excel and then save it. So this is the first step of Rahul, which we can replace with RPA. So there we can get RPA. That's our first step. I hope I was clear. Next, now what happens? Assume for same Rahul, the invoice is not a regular one. So he got his RPA is able to read this type of invoice, but next time from next vendor he received a different kind of invoices, different structure. So how do we handle it? How do he handle this? That's when artificial intelligence comes into picture. So RPA can do a repetitive task which is rule based and logic based. if something apart from rule-based and logic-based comes into picture, RPA cannot handle because it doesn't have any prior knowledge, or it doesn't simply, in simple words, it doesn't have brain. So artificial intelligence comes into picture where it gives the brain to RPA. A robot with brain is nothing but we call it intelligent automation. So you add an AI to that so that it can do what human does. Let's understand what is AI. So in simple words, again, AI is a simulation of human intelligence in machines. So let's say you have an apple, you see it, you see the structure of the apple. It will have a stem in the top. It will be almost red color, and it will be almost a round in shape. So with these things, you will identify apple as an apple. Say in similar way, if you want to teach a machine to identify an apple, you give some training to it, and then you'll make it understand. So this technology is called artificial intelligence, and this will include reasoning, problem solving, perception, and language understanding. So okay, I think it's got muted. Thank you.
No, I don't know why it is happening. Though I have muted them and I've doing it, but still it is getting like they are able to unmute themselves. But you can go ahead, Krishna.
Sure.
Sorry.
Sure. Okay. Okay.
Yeah.
So with that, so we have artificial intelligence. So there are other subfields also within artificial intelligence. We have machine learning. So artificial intelligence is a main set. Let's say self-driving cars. So self-driving cars will have capability of cognitive vision. They can see the traffic in road. They can identify the vehicles, and then accordingly they can control. So that's a whole picture of artificial intelligence. Within that, let's say you will have Amazon, you have some voice assistant within the car. So that needs an ML algorithm. So that's where ML comes into picture. Within that, from your text, it has to understand the pattern, right? So that's where deep learning comes into picture. So this is a whole set of artificial intelligence, and then machine learning and deep learning are subsets of AI. Now let's get back to our example again. Now same Rahul. So he previously he had an RPA bot. So whenever he sees a different kind of invoice, he's manually doing it. Now with AI, you can add cognitive ability, right? So you can there are OCR engines, and AI with certain training to OCR engines, you can make a machine understand the different types of invoices. So with that, when you involve AI there, with the different kinds of invoices also can be read, and then that invoices can be handled. So that's where AI helps Rahul now. So that's about AI. And now let's see how AI, how the evolution happened from AI to generative AI. So back then in 1950, so Alan Turing, so he started this entire theory of making machines learn. He had this question like, can a machine exhibit intelligent behavior from a human? So that's where the whole idea started. Then the foundational idea behind AI is to set the stage for future developments. So that's when in 1950 Alan Turing started this, and then later in 1966 one of the first chatbot was created, which is created by MIT, and then later neural networks. So from a chatbot, neural networks evolved, and from there to long short-term memory (LSTM), and from there GRU and attention mechanisms. This is where the start of GPTs happened. Like the concept of transformers were created here, and then from there, a proper architecture was firstly created on 2017. Which there is a paper called "Attention is All You Need." So from in that paper, this entire GPT transformer architecture was clearly mentioned. So that's where the start of GPT happened. Later, the LLM creation happened. The first one was GPT, OpenAI's GPT. Here, the term GPT means generative pre-trained transformer. So we'll exactly see what does generative pre-trained transformer mean. So OpenAI used this transformer and then started building a GPT. It's called OpenAI's GPT, which can understand human and then generate data back to us, which is what we are using right now, ChatGPT. And then later, a rise of LLMs happened, and then GPT-3, GPT-4, and then we have Claude, Gemini, and then the LLM era got started from 2020. So that's an evolution from AI to generative AI. Now, I think you always right now. I think you will be hearing the term artificial intelligence everywhere. So I think in colleges also it is common that you have to learn AI. In if you, I mean, you can compare. You can already feel that, and in your life you can already experience AI. In simple words, if you go to an email and then if you type like I'm disappointed because, and then rest of the sentence it will suggest. So that's AI simply. Next, generative AI. So in AI, we have, how does AI work? Let's understand in simple words. Let's not get into a deep definition. So AI works with data. So you will have certain training data. You write an algorithm. You give that training data as a training data to algorithm. With that, you build a model, and then from that model, you will start predicting, or you'll start making to make actions. So as you, if you remember, I started with training data. So you need training data to start a build to start and to start writing an algorithm, and then from that you will build a model, right? So what does generative AI mean now? So you don't need to have a training data. So you can the AI itself, generative AI itself will answer you without any training data. You just type it, you ask like I need certain details, it will generate based on your request. So this is also a category of artificial intelligence which focuses on generating new content. So without training data. So let's say you ask ChatGPT like I need to write an email for certain things. It will automatically generate, right? So you didn't train that model. You're directly consuming it. So that's what generative AI means. So with the information that you give, it can generate new content. It can be images, it can be text, it can be music, or any other form of output, which is creative. So that's what generative AI means. So in detail, let's understand with a simple example. Make a big screen. So let's assume this entire cake making process as a generative AI model. So you give a prompt, just like how we give input to a cake making processor, you give flour or dough, right? So that will be your prompt. You'll give a prompt in the top, like make a cake, please. That will be your prompt. In traditional AI, like in previously discussed AI, what happens? You might have to give training data, right? So here you don't have to give it. You give a prompt, make a cake, please. That will be your input. So assume that is that's a prompt. It'll generative AI will pre-process it, and then it'll have a transformer architecture with neural network. With that, it'll understand with its already trained data. It'll understand your prompt. It'll clean that prompt. It'll clean that sentence and then tokenizes and then converts into a small tokens. That will be pre-processing step. And then with neural network, it'll with its vast already trained data, it'll understand what is your intent to do. I mean, you want to make a cake place, right? So it has to understand the intent. So using neural network, it'll understand the intent. From there, it will generate a first sentence. It will create a pattern. That will be your first output. Later, once the first output generated, it will fine tune on it. It will fine tune on it, which is called general training. So later, the fine tuned specific data will be shown to you, which is like a uptake. So you give one input, it will take it, it will pre-process it with neural network. It will understand with its existing data that you ask for a cake, so it will identify. It'll get the steps required for cake making. It will do it, and then finally it will give you the output, like just like our cake maker gives you a frozen cake. So that's a simple way to understand generative AI. Let's go to next step. Objectives of generative AI. So as I mentioned, with generative AI, you can AI that can generate data upon your request, upon your input, right? So there are like huge objectives which you already know. Let's say ChatGPT, you simply give the prompt, you ask, you need something, and then it will generate. That can be a big objective. And additionally, what it will do, the repetitive part, generative AI can do. The creative part, human can do. So in that way, it will increase our productivity. So these are the main objectives of generative AI. It will also help you in solving complex problems. Let's say you need to solve a complex problem, but you have to apply complex formulas to that, which you right now which you don't need. You can directly use generative AI. You type, you ask whatever formula you want, it will automatically answer you. So that's these are like basic objectives of generative AI. Next, large language models. So we now understood what is AI and how it evolved to generative AI, and then what is generative AI, right? So LLMs are set of AI models designed to comprehend and generate human language. These are like the text that you give, right? So to understand that, you need a model, right? So that those are large language models. So behind generative AI, there is a model associated with that. So that model is called a large language model. So why do we call it as large language models? Firstly, large. Large means a huge size and complexity of these models, which will contain hundreds and millions of billions of parameters. What does that mean? I don't want to go into detail, just understand in basic terms. Let's say you have an Excel file, you have a number of rows. So with that, if you train a model, that can do the things which are available, which you trained within this Excel. But to make any task, you need huge data, right? You need every possible data in the entire world. So that data is called a large data. Consider it as a large data, which will contain every detail related to everything in the world. So that each thing in the world, let's say a textbook, a science textbook will contain related to data related to science. That can be one parameter in that huge data, in that huge data set. So that's why we used a term called large. Next, language. This denotes the primary function. This will make understand that the LLM is used to generate a human language, right? So in LLM, language denotes a primary function, which is to understand and generate the human language. And model, it's a mathematical representation that captures patterns and structure of large language data. So if you if you understood properly about AI, so we'll have a model, right? So that model, so the same AI model, generative AI model, same. Here, difference will be it will be a little huge, not little, it will be very huge. So that's about a large language model. And what is its role? LLMs will provide a foundation for generative AI. As I mentioned, generative AI, the core point or the behind scenes of generative AI will be a LLM. So you create an LLM, you use an LLM to generate something. That's entire technology is called generative AI. So the LLMs are the key functionalities of generative AI. So in this circle, you can see already, maybe it is a little small. So all these are generative AI LLMs. For example, Sora.ai. So these are end applications that developed upon an LLM. So LLMs are GPT-3, GPT-4, these terms, and Claude AI, Gemini. So these are LLMs. Upon that, you build some applications. Those are this, as you see here, like DeepSeek, then GitHub Copilot, and then you might have heard about Sora.ai, also Jasper, Bing. So all these are applications built on generative AI applications built on LLMs. And we call those as foundation models, which are nothing but LLMs again. So these are some of the widely used large language models. Let's say the famous one, ChatGPT 3.5, 3.5, and then 4. This is the current version, which is developed by OpenAI, which helps us to generate content. It can summarize text. It can also analyze sentiment from the data. Also from Google, we have Gemini. It will be mostly used for complex problem solving and code generation. And then from Meta AI, we have Llama. And then from TI, we have Falcon. And then from Anthropic, we have Claude. So these are the famous LLMs that are currently used in current market. So we might have a question like, how does LLMs get so smart? So how they are answering whatever you ask? So the reason behind is that LLMs are trained on huge amounts of text, like textbooks, websites, and conversations. And then these LLMs learn pattern on how human can talk and write. So that's why they are smart. Again, a simple example, like just let's say you type like once upon a time. LLM can finish it like saying there was a dragon who lived in a cave, something like that. And this generation is not, it's not copying it from some other website or something. It is creating it based on what it learned. Okay, I hope I was clear. I think these are huge terms, and then I've covered it in small time. I'll quickly take some questions maybe. What is the purpose of industrial automation or RPA? So I think you might have skipped or missed the first slide. So the RPA. So RPA is nothing but it's a technology which is used to create software robots. Let's say you have let's say you are a student, right? You might have to write some assignment and then submit it every quarter, right? So this writing you manually do. Let's say you have to do it in a Excel file or in a Word document. You have to copy something into a Word document. You have to rename it and then send it to your professor or something. So these manual actions were there, right? So if you want to make a robot in that place, so that's where RPA comes into picture. You can create a software robot which exactly mimics human actions, and at the end, it can submit. So these steps can be done using an RPA. So that's what an RPA technology means. But the only disadvantage is it doesn't have a cognitive capability. It cannot understand uh, beyond what you tell it to do. For example, it is rule based. If you ask like um, think by yourself and then get the latest or get the latest document from website and then submit to professor in an assignment, it cannot do because it will do only what you tell it to do. These are rule based. Okay, so now we understood what is RPA. So RPA with intelligence. I mean, if you want to add intelligence to RPA, that's when AI comes into picture. If you don't have enough data and then you still want to do AI, it has to generate by itself. That's when generative AI comes into picture. How is generative AI working? Behind generative AI, we have something called LLMs. So that's when all LLMs comes into the picture. I guess so far it is clear. And now, what is an agent? So agent is a AI powered entity. Let's say in the same story that we discussed before, Rahul case, now he has to do everything manually, right? In case if there is a new invoice, he has to involve AI there. Still, he has to retype that. He has to generate the code and then he has to deliver it, right? So let's say this entire thing can be done by something with a simple prompt. So let's say you have a document. You simply type like extract um, price details maybe from invoice, which is this invoice. With a simple prompt, you have to get the work done. So that's when our agent comes into picture. So it can think by itself. It can involve tools that are required to do the task. In case if there is any failure, it can escalate to human. That's the entire job of an agent. Now let's understand from the definition. So an AI powered entity which can follow instructions, as as I mentioned, you can just give a prompt, it will get that prompt, and then it can analyze instructions from that. It can use tools whenever required. If required, it can run automations, and the whole point is it can make decisions on its own, and it can interact with its environment. Let's say I gave an invoice and then asked, and then I told an agent to get information from that invoice, right? So it can understand that environment like it's a document understanding platform. I need to understand a document, and from that I need to collect some information, and then I have to give it back. So it can with that, as I mentioned, so it can understand the environment. Also, it can do the complex part. So let's say there is as I mentioned before, if the invoices that are coming to us are different, they are not in a common structure. At that time, it has to understand the complex structure, right? So that part also an agent can do. That's what a basic agent means. So these are few key principles of an agent. Firstly, planning. It can understand the given set of goals and then plan actions to achieve them, and then tool usage. So let's say in my case, um, in let's say Rahul's case itself, after extracting details from invoice, these details needs to be added into a system called assume for your college there might be a database, right? Let's say after extracting details from an invoice, it has to be entered in a database. Let's keep it as database. So this entry part, it's an automation again, right? So this entry part to do an automation, it needs tools, right? It needs an RPA or an RPA job to finish this task. This can be an RPA tool. So whenever required, it can get the tools, and then it can make use of tools and then do complete your required task. So in the prompt itself, you mentioned extra details from invoice and then enter those details into DB. So if you mention this, if you're asking it to write these details into DB, it needs something to do that, right? So that's when RPA comes into picture. So it can involve RPA also. So that's what tools usage meant. Next, context. So context is nothing but data source. So it's like a database for an agent, which can understand. So let's say you are building an agent for the same purpose. You're building an agent for invoice extraction or data extraction from an invoice. So the data extraction, it needs some context, right? What needs to be extracted from that invoice? If you have specific requirements, unlike a general requirement, if you have a specific requirements, like in your college base, let's get back to this example again to understand better. So in general, invoices will have company name and then issued, pay to, and then some details. Let's say for your college, you have a different invoice. You have like college name and then the year of the college, year of education, like currently if you're in second year or something, if you will have specific details in your invoice, right? How does an agent understand? So for that, you need a specific context, which is only related to your college. So uh, you will have details like college details maybe, and you'll have yes, uh, like types of degrees. So these information will be specific to your college, right? Types of degrees, and so on. There can be many details specific to your college details. How do you train the agent to specific to your details, specific to your college details? So that's when context comes into picture. So you'll have a specific data which you want agent to be trained on. So that's when context comes into picture. That is also called as context grounding. Adaptability. So this is one of the key capability that we are missing in RPA, right? If there is a environment difference, or if there is any rule, or else if there is any cognitive ability that is required, or a thinking capacity that is required. It cannot do by itself, right? It needs to, you need to manually tell it, and then only it can do it. So agents can automatically adapt it. So you give it, it can understand, it has its own brain, so it can understand and then it can do reflection and memory. So in case with all this, if an agent was not able to do what do your requirement, you will manual, then you will commit, you will tell agent like, okay, you made a mistake, you solve it, or you recorrect it, or you correct it. So that's when it will understand from that new requirement, and then it will store it in its own memory. So that's what reflection and memory means. So with all its memory and with all its capabilities, with all its context, still it was not able to do something, you will tell at that time, right? So that memory will be stored again and then will be used. If the same situation comes in future, it can do by itself. So that's what a reflection on memory means. So that's what an agent is. And then keep these are the key principles of an agent. Now, what do I mean by agentic automation? So we understood what are robots, what are RPA robots. So these are mainly rule based. They act predictably, and then predictably, and then deterministic decisions, like limited decisions. You tell a decision to it, it will only do that decision. It cannot go beyond that, right? So that's what robots are. Assume you give a brain to robot, and these are goal based. So you give certain goal and then it will do. And then unlike it will be when other than information comes into picture, it will robots need human intelligence, right? So it doesn't need it, or agents doesn't need any human intelligence. It can act independently, and then decisions it can take dynamically. And which is suitable for what? RPA robots, when the task is routine, it's like not you don't need any brain in that task. You just need some steps need to be performed, uh, which are like very routine and then which are very common. There is no dynamic decisions involved. That's when you can use RPA. With advanced, like you don't know what situations may appear in future, but that's when agents come to the picture. These are best for ad hoc tasks. So you give something, it can decide by itself and then it can do. So those are basic differences between robots and agents. Now, what is the term called agentic automation? So this is a combination of AI, automation, and orchestration. What do I mean? So we have RPA, we have AI, and we have automation. So just how we discussed in our use case. So for extracting details from invoice and enter those details, this is the prompt that you gave. And then now you want to use agentic automation for this use case. So firstly, what will you do? You create an agent. You tell the purpose of an agent, like you create an agent, and purpose of agent will be extracting details from invoice and then enter to DB. This can be a purpose of the agent. Now, what does agentic automation mean? So within this prompt, it needs capability to think. It needs AI to extract details from invoice. It needs a tool to enter these details into DB, right? So the first part, to do the extraction from invoice, we have AI involved. So that's where the combination of AI comes into picture. And then to enter those details into SAP, we need RPA, right? So that's when automation comes into picture. To to manage this entire workflow, you need an orchestration, right? So where the flow goes or what happens next. So all these will be orchestrated in a place. So that's where orchestration comes into picture. The combination of entire things are nothing but agentic automation. And agents, as we discussed before, agents have AI skills. They can communicate in natural language. You give the step, you give the task, it will plan sequential steps from that task, and then it can involve other agent also within itself if required. That's these are the main capabilities of agents. And as I mentioned, agentic orchestration, specifically from UiPath, you have an ability to orchestrate all these robots, agents in a single place. So that's what agentic orchestration means. Yeah. So this is the way that we come from transition from RPA to agentic. So for RPA, you need 100% people create and maintain automations. Once we create an automation, we need to manually maintain it 100%. When it comes to agentic, some cases 80% of humans and 20% agent, 20% of agent, and then 20% of humans and 80% of agent. At the end, the goal is to become completely agentic. So from an RPA, initially you create a small agent and then you help the agent 80%, and it will further evolve. In a few days it can evolve, and then agent can do 80% of the task, and then humans required is only 20%. And at the end, after certain days, completely an agent can do entire task. So we understood the AI capabilities of an RPA, and then we understood what is an agent as a high level overview. We also understood what is agentic orchestration mean. Now let's understand the roles, activities, and then key differences of where RPA comes into picture and where agent comes into a picture. Let's say this is a human body. Assume this is your use case. So the acting part, the tools part. So where you perform some actions. How do you type? You type with hands, right? So the acting part or the action part, you need robotic. You need RPA. Like for example, sorry, for example, receive and respond to customer queries, process product orders, and then respond for refunds, post product promotion. So these are common tasks that are required. Doesn't require any brain to think of. So there will be specific steps to do. You create an RPA for that. The specific steps will be carried out. So for this part, for acting part, you need a robotic. You need RPA. When there is a need to think of for a certain task, that's when agent comes into a picture. So agent will be a brain of your task. So agents can act, they can do activities, they can understand from knowledge based articles, for example policies, or as I mentioned, if from your college DB, from your college DB it can understand what type of data your college is dealing with. So it can understand the knowledge context. From that it can also do quality measure, or it can also create KPIs. um, in simple words, like let's say what is the input context will be like what is the data or documents to be processed. It can give you like provide output in a format. So these input and input context and output instructions, it will be more clear when you understand the when you start creating an agent. So you first tell the context of what it needs to be done. So like context will be like what is the data or documents to be processed. You will also tell the agent how you need an output. So let's say from the extracted data from the document, you need that in a Excel format, or you need it in a table format. So you mention that. So those instructions also you give. So the process of giving all this, and then making a task or making a robot think itself, that's what is called agentic. And these are the main key differences between an agentic and then robotic. Also, you can understand it like a left and right brain. So left brain, assume it as a RPA, where you'll have structured, logical, and systematic processing. There is no need of thinking capability. There is no need of cognitive. It You just give some sequence of steps. You want the robot to do those. The robot will do it. So that's robotic part, which is left brain, and then the right brain will be the creative part. So where we need a decision to be taken dynamically, when you need to add some creativity to the output. So that's when agentic comes into picture. There is this myth called RPA will be replaced with agentic automation, or there is no future for RPA. So future is completely agentic. So all these will be myths. I would say like the future will be both agentic and robotic. Why? I mean, how am I saying this? As I showed before, agent can think by itself, and it can extract from details from invoice. It can do all these things. But let's say when you want to do some sequence of steps, Let's say you want to enter these same details into a DB. So that agent cannot do. For that, you still need an RPA or a process automation or an automation task, which will do this entry part. So agent will definitely need a robot to do carry out certain kind of actions. So that's why both we need robotic plus agentic, and the combination will be your future. Okay, now let's understand the components of an agent. From design and runtime, firstly, natural language prompt. Agent will take natural language, which is like plain English. It can understand plain English, and that natural language prompt should consist of input and output arguments, a prompt, system prompt with role, what the agent needs to be taken care of, what is its goal and constraints, and then next user prompt. How user is going to interact with the agent. That will be user prompt. I'll show you in a simple example. So, firstly, as I mentioned, for prompt, you need to give input and output arguments. You need to give its proper role, goal, and constraints, and then you need to give how a user might ask the agent. So that will be the natural language prompt part. Next, the context. So let's say you are planning to make agent to a specific task and for specific kind of data or specific kind of context. You need to give that context also to the agent. How? Using context grounding. These are like I'll show you in the example. So let's say you have a certain specific data, like as I mentioned, for college specific data, and then when you ask an agent to answer something specific to your college, then you need to tell agent study the details from college database. So that's what context grounding means. So specific context, answer user query from specific context. Next, tools. So you need to add tools that are required for specific agent, like activities, automations, or other agents. So multi-agent is also possible in UiPath. I'll also show this in example. With By giving all this, still an agent was not able to carry out a certain task. That's when escalations comes into picture. So you add an escalation part also. Like if you still are not sure what user is asking, you raise an action item to user. You raise an action item to end user, telling that I need more information. So that's what escalation means. So when you start building an agent in any organization, first things comes into picture. What about the security part? So with agent, generative AI or LLM behind, there is a chance that you give some company related or organization related data to agent, which might used as a training data for an LLM, right? So you have to stop that when you start building to organization specific agents, right? So that's where for that, to solve that specific problem, UiPath is coming up with a term called or a technology called AI trust layer. So what does this AI trust layer do? Whatever you give to the agent, whatever prompt you do, or whatever data you give to the agent, that will specifically lie in the organization itself. It will not be used for further training to the LLM. So that's the main usage of AI trust layer with the LLM. So when someone asks you like, what about the security, you can mention that UiPath comes up with a AI trust layer, which will not which will restrict training an LLM with your specific data. So that's what AI trust layer means, and that would be our definitions part, the concepts, understanding the concepts part. Now let's see how UiPath is giving you, or how does Agent Builder platform looks like. So if you have a community cloud, you will already see a tab called agents. You can just click on it, and then this will be your agent builder. So as a home, I mean, you can quickly go through platform. There are like a few important dashboard elements. In our next session, we'll start creating an agent. I'll go in detail at that time. So for now, I'll just show you how an agent looks like. So assume you want to build a stockbroking agent. Let's say this agent needs to get you'll give a stock name, and then this agent need to do web search, analyze the stock, analyze the technicals and fundamentals of the stock, and then it has to give it has to tell you that whether you need to buy or not. So that's your entire task. Assume that's your entire job. Now in traditional RPA, what will you do? We'll develop an automation to go to certain website, you enter the stock name there, you extract the information from that. Still, you will not be able to understand, or an RPA robot cannot be, it cannot understand the pattern from that text and then tell you if you can buy it or not, right? So in agent, for that specific use case, you start creating an agent. So you can select the model. As I mentioned, it uses generative AI. And then for generative AI, what is the base for generative AI? An LLM model. So this is your LLM model. So we select the model. So you name the agent. Will quickly tell like what it needs to do. Get analysis for a specific talk. So as I discussed here, natural language prompt, right? So that prompt comes here. So you need to give a specific role in system prompt. You need to give a specific role that you are a stock analyzer. Get the stock from the input and then give me good analysis. And then you need to quickly give the description, like check the stock name, analyze fundamentals, and give the output for buy or not, if I can buy or not. And then output format. So if you want output format to be in a table, you can write like I need all technicals and fundamentals in a table, and then a single string called you can buy or not. So that you can format here, and then the escalation part I'll come in the below. So that will be for system prompt. One more thing that we discussed here was about inputs and outputs, right? So how do you give the stock name to this prompt? So that's when arguments comes into picture. Click on arguments. So whatever you wrote here, so that will exactly match as an input argument. And then you can, once you add that, you can click on confirm, and this apple will be passed as an input argument to the prompt. User prompt. In my case, it's simply stock name. In your case, like let's say you are, as I mentioned, our great example to extract in data from invoices, you will mention it here like extract details from, and then that invoice name you can give it as an input. So that will be your user prompt, like how user is going to give the prompt that you can mention here. So that's about natural language processing, right? The first part, natural language prompt. Next, the context part, the tools and context part. Tools. So currently what I need, so with this information, it needs to go to a website or a Google, and it needs to search and then get the information, right? For that I need to add a tool. So my tool here is web search. So how do you add that? Simply click on go back simply click on add tool, and then here you search for web, and then you'll get the tools related to web. So I need to do a web search, so I selected this here, and then this comes automatically. All you need to do is you just have to pass this argument. You can I'll show you when we start building an agent. So that's about tool. So now we gave prompts, we gave the tool. Now if you need to get information from specific context, that's where context learning comes into picture. You click on add, and then you create a context, and then use that context in your agent. I don't want to create any now. And then with all this information, still agent was not able to do particular task. You will add, if you add an escalation here, it will generate an escalation to the user. It will send an action item to the user. Doing that, I cannot do this. Please help me, something like that. Now we gave the stock name, we gave the system prompt, and then let's run the agent. So I have tool included in web search. So web search started. You can see that it got information related to Apple. And then for buy or not, basically LLMs will be trained to not suggest you about stock market. So that's why it is giving analysis, like based on the analysis. Apple appears to be a stable investment with strong fundamentals, and then it may be a good buy for long-term investors. So that's how you build a complete agent. Okay, I think that's all. So at the end, if you want to learn about all these things, you have Academy, and then if you have any questions, we have your path forum to answer. And then you just log in, keep checking your path community page. You'll be getting more community events to learn about these upcoming technologies. Now we'll take the questions.
Guys, you can ask questions. We are opening the floor for question and answers. Uh, there is something called raise hand. You can use that feature, or also you can chat. You can type the questions in the chat box. Krishna will be answering those questions. This entire session is recorded. Give us time till tomorrow or till Monday. You'll have the recordings available on the community forum. Krishna, how this agent work efficiently?
Okay. How these agents work efficiently? So efficiency will be a point where you it depends on how you build an agent. Let's say you exactly know what an agent do. It all depends on how you give the uh, system prompt and then the user prompt, and then how well you gave the context to that agent. Based on these terms, based on this number of properties, the agent's efficiency will be depend. I mean, depends on your properties that you gave to agent. Let's say with all these, it's still not able to do the task. As I mentioned, you'll have something called escalation, which you can tell the agent, you can correct the agent on the next time it will do by itself, if that comes into the picture. I mean, if that thing comes into the picture.